Imagine Africa, millions of years ago. Paleoanthropologists have reconstructed paleo-environments, showing that climate conditions were shifting from warm and lush forests to drier, open savannas. How did hominins adapt to survive in this ever-changing environment? Researchers have discovered that the environment was the driving force behind the evolution of bipedalism, the reason early hominin diets varied and changed, and why there was a diversification of multiple early hominin species. The first of three major hypotheses that explains these shifts is the Savannah Hypothesis, which suggests that as forests shrank and grasslands expanded, early hominins adapted to this new landscape by moving to bipedal locomotion. This adaptation would have helped them travel longer distances in open areas while keeping their hands free to carry food or use tools, two huge advantages. The second hypothesis is the turnover pulse hypothesis. This idea suggests that in times of extreme climate change, like the Ice Age cycles between 3 and 2 million years ago, species with flexible diets and behaviors just survived better. Animals with specific diets faced greater challenges, while those who adapted, like early hominins, found new niches, helping them to survive and diversify. And then we have the Variability Selection Hypothesis, which highlights how constant environmental shifts over millions of years may have selected for flexibility itself. In other words, it wasn't a specific climactic event, but how constantly the environment was changing. Being adaptable in the face of constant change gave early hominins an evolutionary edge, allowing them to survive whether the climate was wet, dry, or anywhere in between. So, how did bipedalism develop in response to these environments? Scientists think that walking upright helped early hominins stay cool under the sun, use less energy over long distances, and most importantly, freed up their hands. But it did come at a cost. Our S-shaped spine, while great for upright walking, is also prone to back pain over time. These theories all help explain why we find early hominin fossils with both arboreal or tree climbing and terrestrial or ground walking adaptations. It's like a mix and match of traits, showing how they were still partially adapted to life in trees, but increasingly built for life on the ground.